There are 5 of them, 5 different postulates that we're going to learn. So I'm going to go through each one of them. Okay, so these different things are postulates and proofs that are going to prove that triangles are congruent. So you're going to get 2 separate triangles like this. Sometimes they're attached, sometimes they're not. And this first one is called SSS. So you'll just see it written like this. So those S's split up, they just stand for sides. So these are kind of pairs of sides. In other words, we have this side that has 1 hash mark and this side. So that's one set of sides. So it's usually a pair. When you see a letter, it's going to stand for a pair of sides, a pair of second set of sides, a pair of a third set of sides. This one has 2 hash marks. It matches up with this one. So there's 2 sides, that's 2 S's. And then a third side or a third pair of sides like this with the 3 hash marks is our third side. This is the easiest one to figure out because there's no fine print with it. It's just 3 congruent sides. So 3 congruent sides of one triangle are congruent to 3 congruent sides of another triangle. Then those 2 triangles are obviously congruent. Okay, so that's called SSS. When you see this, and you will see this all the time in this unit, triangle congruent statement. That means I'm going to do triangle, and I got to name them. Okay, when you name them, you can pick any order to start with, but the order of your second triangle is what's going to matter. So order does matter. So if I do something like BEA, and I go along 1 hash mark and then 2, make sure you put a congruent sign. Make sure you have your triangles. I will take off if you don't have the correct notation. Okay, focus on the notation. So if I went BEA, I went along 1 and then I went to 2. I had to do the same thing over here. So I've got to go this way, CED. So there's a bunch of different options for this, but order matters. The way I do it is I write one statement like this, and then if yours is different, then I just check it along with mine. So if you did something like EBA, then I would make sure that your second one would be ECD. Okay, so there's different ordering of the letters, but the order does matter. Whatever you pick for your first one, the second set matters. Okay, so we're going to go through a bunch of these. Next, I've got what's called SAS. So this is going to have a set of sides, a second set of sides, and this time we have a set of angles. Okay, now the important thing about this, when the A is in the middle, that's called included. So this is an included angle. What that means is the angle is going to touch both sides, just like in the postulate, it touches both S's. So I've got this side with 1 hash mark matching up with this side. And then I've got the one with 2 hash marks. Ooh, that's bad. Matching up with this one. Now the included angle is going to be the angle made by these 2 green lines. So it doesn't make this one or that one. These make this one right here. Okay, same with the red. Those 2 red lines, they make this angle. So that is what an included angle is. All the other angles are considered non-included when we talk about those 2 specific sides. Okay, so triangle congruent statement. My red triangle, I'll call it ABD. So I went along 2, I went with the 1 half mark, and then I went along 1. So ABD. And then for my green one, I went along 2 and then along 1. So ACD. So use your hash marks when you're naming your congruent statement. Use your hash marks and use your angle signs. Those will help you to get the correct order. All right, next is ASA. So this time we're going to have 2 sets of angles. And we're going to only have 1 set of sides. Oops, I put the S in there. Okay, so for example, here's 1 set of sides. They got 1 hash mark. And then I've got a set of angles. It's marked with the little half circles like that. And that's all I've got. Well, the other set of angles, it isn't marked, but you can assume that these angles at E are congruent. The reason why you can assume that is because they're vertical angles. So vertical angles are 100% of the time congruent. If they're opposites in an X, they are always congruent to each other. Notice I put 2. So this one had 1. So that means you got to separate and show the difference. So those angles are equal, but they're not the same as D and B. So those are my 2 angles in my side. Now, just like before, this side has to be included. Otherwise, it's not going to work, or it'll be something else. So just like the side is touching both angles, that's why it's included. It's included inside the A's. So the side, this side that we're talking about that we highlighted, is included in these angles. It's touching both of these angles here and here. It's not touching that angle. So these sides aren't included because they're not touching both of the given angles. So your side has to be included. Let's do our congruent statement. So the green one, I can go DEC. And it's a little easier when you have the angles because you got 1 and then 2. So you got to go 1 and then 2 on the other one. So BEA. Use those hash marks and use those angle symbols so that you don't, because you can't tell if these triangles are twisted without them. Okay, the next one, and so we're on the 4th one. We got 5 of them to learn. Our next one still has 2 A's and an S in it. Angle, angle, side. So we still have 2 sets of angles and only 1 set of sides. I keep writing the S. The only difference here is this side is non-included. It is non-included because it's not included inside the A's. It's actually only touching 1 angle. It's only touching 1 A. So let me highlight here. First of all, the parallel lines, when you see parallel lines, that means there's going to be some kind of piece of information that's in there. So far, here's all they gave me. That's all they gave me. They gave me 1 set of angles. That's it. Okay. Now, here's another invisible. Just like the vertical angles, the opposites in an X, just like those were invisible. Not invisible, but they weren't marked. And you're supposed to know it. So you have to know if you see vertical angles that you can mark them if you need more information. Same with this line right here. So if you see this line right here, it's used in this triangle, and the exact same line is used in this triangle. So if it's the exact same line, it's going to be the same size. You do not have to mark it with a hash mark if you don't want to, but I'm going to just so that you can see it. So that's my side. Okay, and the reason why it's not included is because it's not touching those ones. So I need 1 more angle. Now to decide if it's going to be these 2 that are equal or these 2 that are equal, we're using our parallel lines. So, and this we'll get into a lot more later. But remember, this is from old stuff. When you have parallel lines and a transversal, these 2 angles right here and here are alternate interior angles. And when you have parallel lines, you have congruent alternate interior angles. Okay? So since that's in there, and it had to be these 2, it couldn't have been these 2, because if you notice, the blue lines don't cover this part of the triangle, so it doesn't really work there. It had to be those 2. Okay, so that's what an angle side will look like. So if I name my green triangle, I can do 2 or 1, 2, none. So DCA. And my red one on top, since I went 1, 2, none, I got to go 1, 2, none down here. So BAC. Okay. Last one is HL, and then we'll just get to some examples of how your problems are going to look. So HL, I know they don't have any angles or sides. This is actually hypotenuse, leg. Okay. So since they're separate, I'm just going to use the green for the leg. So the hypotenuse is the easier one to figure out. Hypotenuse 100% of the time is across from your 90-degree angle. Okay, so in other words, across from your 90-degree angle is this one right here. Same thing for this triangle. Across from your 90-degree angle is this one right here. That is the hypotenuse. That will always work with all triangles. All right triangles have a hypotenuse. If it's not a right triangle, it doesn't have a hypotenuse. So that's the easiest way to figure it out. So it's always across from the 90-degree angle. So that's a congruent hypotenuse. And then for the leg is either of the other two sides. So as long as you have another set of sides, this is basically all you're looking for are two sets of sides that are equal, but one of them has to be a hypotenuse. So it has to have a 90-degree angle. So this one would be considered the leg. Okay. Statement. Didn't give you letters. Let's do like this. Oops. All right, so if I did ABC, I went along nothing to the 90-degree angle, and then I went along 2. Okay, so then I have to do the same thing over here. I have to go along nothing to the 90-degree angle, and then along 2 hash marks. So EDF. So I did ABC, and then I did EDF. Okay? So those are our 5. That's the 5 you're going to be working with. You probably won't see HL in your IXLs tonight, honestly, but you will see it. You will see it on Thursday. Okay. So the HL will be left out of the. It'll be left out of the IXL. I did not like the HL that they had in IXL, so I left that one out. Okay. The last thing you're going to see here is CPCTC, which say that 3 times fast. Go ahead. So this is the C. This is what all the letters stand for. It's called corresponding parts of congruent triangles. And I'm going to use symbolism here. If you don't like it, write it out. So corresponding parts of congruent triangles are congruent. That's what all those letters stand for. Okay, so C, P, C, T, C. Okay, that's what that stands for. Now, what that means is once you use one of these postulates to figure out that my 2 triangles are congruent, so if HL works, that means they're all congruent. So that means this one, A, just like we did before, A and E are going to be congruent. So once you have established that HL works, everything else works. So now I can say A and E are congruent. That's because corresponding parts of congruent triangles are congruent. Same thing here, C and F. C and F go together. So once you use one of these postulates, then you can mark everything equal. And that we're going to use this in proofs later. Okay, so I'll show you this. This stuff will come a lot later, but I just thought I'd introduce it now. So the problems you're going to see tonight are going to look like this. It's going to say, sometimes it might have 3 triangles and it'll just say, name the 2 that are congruent. And you got to use your congruent statement, just like we did in the notes. So this will say, determine if the triangles are congruent. If so, write the postulate. The postulate are the 3-letter things, like ASA, SSS. That's what that means. So if you don't know what postulate means, that just means something like this. Okay? So that's all we want to do. We want to say yes or no. And if it's a yes, we write the postulate. If it's a no, it's just a no. So in this case, I've got 2 angles and a side. So the only one that has 2 angles and a side, it can either be this one or this one. And you funny guys, there is no angle side. All right, so we got to determine which one works here. So if you have 2 sets of angles and 1 set of sides, then it's going to work. You just got to figure out which one. So in this case, if you look at my side is only touching 1 angle. Same thing over here. My side is only touching 1 angle. So what that means is my S can only touch 1A. It's not touching this A. It's not touching that angle. So this is non-included side, which would mean that is this. So this is a yes. And it is AAS. Okay, down here, this is the most obvious of the 2. You don't even really have to think about it. I've got 1 set of sides, 2 set of sides, 3 set of sides. So 3 sets of S's is SSS. Now, you don't have to write yes. If you write a postulate, I'm going to assume you mean yes. So it's basically either a postulate or a no for me. Okay, down here, I've got 1 set of sides. That's an S. Another set of sides. That's another S. And an angle. That's an A. So the only one with 2 sides and an angle is this one. Now, I have to decide and make sure the angle's included. If the angle is not included, this is a no, okay? My angle is included though. If you notice, it's touching both S's, so this will work. If they had given you, say, this angle and that angle, then this would have been a no because the angle is not included. All right, over here. Right now, what you see is two sides. So again, you can start off that way. I've got two sides. Here's a side, here's a side. I got another side. So I've got two sides, and I've got an angle, but this one is not included. Here's the trick. When you see that 90-degree angle, the first thing you need to look for is HL. I would definitely recommend looking for HL to start off with because SAS doesn't work with that one. And I don't want you to think it's just a straight no because it could have a hypotenuse. So if you get a 90-degree angle, the first thing I want you to check for is HL. And then if it's not HL, you can check for the other ones. It might be SAS. But this does have a congruent hypotenuse right there, and it has a second side. So that's your hypotenuse leg. Okay, 100% of the time you see a 90-degree angle, don't just assume it's hypotenuse leg, but that's the first thing I want you to check for, because usually that's what it is. Okay, next, one set of angles, that's an A. Two sets of angles, two A's, and then one set of sides. So if you have two angles and a side, it's definitely going to work. You just have to figure out which one it is. Okay, so my side, it's touching both angles. So my side, my S needs to be touching both A's. This is an included side, so this one is ASA. Okay, pause me, try the last three. This one right here, I've got one set of sides, that's one S. Two sets of sides, that's a second S. And one angle. The only option is this. So it's either that or no. So I got to decide if my angle is included. My angle is touching both sides. So my angle is included. It's touching both S's. So this works. Okay. Next. Set of angles, one A. Another set of angles, two A's. And a side. So this is, if you have two angles and a side, it's definitely going to work. You just have to decide which one it is. So in this case, my side is only touching one angle. This side is not touching that one. Same thing here. We're only touching one angle. So my S can only touch one A. It's not included. So this is AAS. And one angle, two angles, and a side. Again, two angles and a side, it's definitely going to work. We have to decide which one it is. So my side is touching both angles that I circled. So that means the S is going to have to be with both A's. So this one is an included side. This one is ASA. Okay, the only other type of problem that you'll see, and this is probably more so the type that you'll see on the IXL stuff. Okay, this says determine which ones are congruent. If so, write a statement. So that congruent statement that I talked about. So it might be a no. We'll see a no in here. One set of angles, two sets of angles, and a side. So we know it's going to work. So this is ASA. So yes, it works. And if it's a yes, the directions tell me write a congruent statement. So I'll be doing GHI. Again, you can pick any order for your first one. Then it matters of the second one. So I went 1, 2, none with the angle signs. I'm going to go 1, 2, none with the other one. So J, K, L. It's pretty easy when they're facing the same way. You don't really have to, you just go the same order for both of them. But if they start to get twisted around like normal, then you're going to have to use your angle signs and your segment signs. Okay, so next. This one is a yes by side, side, side. It didn't ask for the postulate, so you don't have to put it. You only have to put that if it's the postulate. But this is a yes. So if I do this, again, the triangles are facing the same way. It's pretty easy. So if I do ABY, you figure out what would be the other one. The other one would be EFN. Okay, that's all we're doing for the rest of this. Down here, this would be yes. I see the 90-degree angle, so I told you the first thing you want to check for with a 90-degree angle is hypotenuse leg. But this time, hypotenuse isn't working. So this is not HL. So let's see if it can be anything else. I've got two sides. So one pair of sides here, a second set of sides here. So two S's and an angle. So it can be a 90-degree angle, or it can have those little half circles. And this one does have the included side. So this is actually SAS. Now my triangles got switched around here, so it might be a little different. I'm going to say F, I think that's an E. Yeah. So I'm going to go FED. You figure out what the other one is supposed to be. So if it's FED, then you have to go WOC. Okay. Next one. This is congruent by ASA, angle, side, angle. And then I'm not going to do the congruent statement. I'll just do it real quick. So I'll do QRS. You do the other one. It'll be TUV. So that one's nice and easy, quick and easy. Down here, it got switched around. This one here will be side, angle, side. Okay, the angle is included. So I'll do WXZ, or I'm sorry, YXZ. And then order over here doesn't really matter as long as you put the W in the middle, because these two sides are equal. So guess what? That means these two angles are equal to these two angles. So a lot of that stuff's equal. If you have a isosceles triangle, then you're going to have two equal angles as well. So as long as your W is in the middle, the U and the V can interchange. So it could be VWU or UWV. Okay, this one's angle side, so it works. I'm going to do CAB. And the other one would have to be EDF. Okay, I got a couple more. I'm just going to go through these. I'm going to go a little quicker on these. Now, this one has an invisible piece of information. They don't mark it. The thing that's not marked is the shared side. It's used in this triangle and this triangle. So this is angle, side, angle. So I'll do ABD. You figure out the other one. The other one would have to be DAC. Because I went 2 half circles, none, and 1. So you had to go 2 half circles, none. Oh, hold on. Eyes. So I went 2 half circles, none, and 1. I have to go 2 half circles, none, and 1. So DCA. Okay. Same thing over here. Hidden piece of information, invisible. That's this one right here. It's a shared side. Okay. So if I did OHP, then you would have to go EHP. Because if I go 1 tick mark and then 3 hash marks, then you got to do the same thing. 1 tick mark here and then 3 hash marks there. Okay, 13, hidden piece of info right there. This one, I've got 1 set of sides, 2 sets of sides, this one here, and then an angle. So the only option is side, angle, side. The problem is the angle's not included. We would need these ones. So this one doesn't work, which means this is just a no. They are not congruent. So there's an example where it might look like SAS, but the angle is not included, so it doesn't work. Okay, this one over here, we only have a set of sides. This one and this one. Now it does show me that my lines are parallel right there. So I've got parallel lines. I've also got an invisible piece of info. I've got those right there. So those are my vertical angles. And then anytime you see parallel lines, you will be able to use, I'm sorry, you can't see through my picture. You will be able to use alternate interiors. So you can either use this line as a transversal, it doesn't matter, or you can use this line as a transversal. If you pick the other ones, then you would get the other 2 angles. It doesn't really matter. But these ones are alternate interior angles. So with what I marked, then angle, angle, side is going to work. Okay, so I would do ACB. And so I did 2, 1, none. So I would have to go DCE. All right, last two. So this one, hidden piece of info. So always want to look for a hidden piece of info. 3 things to look for hidden. Vertical angles. So that might be something good to write down. 3, invisible. If you don't have enough info. Right now I knew I didn't have enough info because I only have 2 pairs of things. So maybe you can think about the hidden stuff. So the hidden info is going to be vertical angles. If you have a shared side like this one right here, or if you have parallel lines like that one up here. So if you have parallel lines, you're going to be looking for alternate interiors. Okay, those are the 3 things, 3 invisible pieces of info that you can look for. Okay, so if they don't give you enough information in the triangles, make sure you look for those 3 things. In this case, I've got 2 sets of sides. There's one there. Here's another set of sides. And my angle. So the reason why SAS doesn't work is this is the included angle, which is not given. So this is another no. They are not congruent. Okay? First thing I told you to look for with right angles, HL. So there's my hypotenuse. It's got markings. It's congruent. We're good. And then I've got legs. So this is by HL. If I do it like that, I will do PQS. And if I do PQS, I went along 1 and along none. So I got to go along 1 and then along none. So SRP. Okay, so there's a lot of information. It was long, but I wanted to give you guys a whole bunch of examples because we are merely building on this. So you have to get this to be able to understand the proofs. Okay, so we are going to build on all of this stuff. Your IXLs, those are the 3 that you're going to do. K5 is going to be more like the ones where they just ask you which, they're going to give you 2 triangles and say which ones, if it's a postulate, okay, let me try that again. Are the 2 triangles congruent and which postulate? So that's going to be like K5, a lot that we did today. K1 and K3, they're going to give you 3 triangles and they're going to say which 2 are congruent by, and then they're going to be SSS, ASA, something like that. And then you just have to give the congruent statement. So these 2 are more like give the congruent statement. K5 is tell which postulate.